We are from Experimental Junior High School of Iron Archery, and we will present you the hydrostatic pressure and the Pythagorean Cup.
Force is a physical quantity. It is perceived by its effects, changes the motion of any object it is opposed, it can cause deformation, it's a vector quantity, and in the SI unit we use for force 1 Newton.
Another physical quantity is pressure. Pressure is called the force applied vertical to the surface of an object per unit area over which that force is distributed. Pressure is a scalar quantity, and the SI unit for pressure is 1 Pascal, or 1 Newton per square meter.
Air pressure. Gravity pulls the molecules of the air to the earth. The weight of the air around us is called air pressure. The air pressure is the same to all the directions. Pressure is power per unit of aggregate.
So the first time who calculated the air pressure was Kelly. He filled a tube with mercury and he turned it in a bowl. So he noticed that the mercury stopped at a certain point in the tube, and he came up with a conclusion.
The pressure exerted by the mercury of the tube is equal to the pressure exerted by the air on the bowl.
So hydrostatic pressure. The hydrostatic pressure depends on the density of the water, the gravitational field strength at the surface of the liquid, and also the depth from the surface. Static fluid pressure does not depend on the shape, total mass, or surface area of the liquid.
Pressure in a point of a liquid. The pressure in a depth h from the free surface of a motionless liquid is 1. The result of the weight of the liquid which is applied to the surface in this depth, which is the hydrostatic pressure, plus the pressure which is applied to the free surface of the liquid, which is the air pressure.
The pressure in an object is always vertical in all directions. The pressure does not depend from the orientation of the surface. It is the same in all directions. Although pressure doesn't have a specific direction, force does. So we design arrows to show the direction of the force, not the direction of the pressure.
A change in pressure at any point in an enclosed fluid is transmitted and undiminished to all points in the fluid. This happens even when the liquid is in different but communicating vessels.
Now, hydrostatic pressure and law of communicating vessels have many applications, such as water supply systems, where the aqueduct is located higher from the houses, and in artesian wells, where the water is pouring out on its own, forming a spout. Here is the aquifer, and in this area we have a well.
Another application of the hydrostatic pressure is in dams. Since we know that the bigger the depth is, the bigger the pressure gets, we build the dams in a specific way so as they are bigger in the bottom.
Now, another application of hydrostatic pressure is the cup of Pythagoras, or known as a Ferro cup, which is a system of returns of overflowing. We can liken the shape of the tube to a drinking straw which we have vented enough. In the central column, there is a hole which communicates with the hole in the bottom of the cup through a tube.
When the cup is filled with wine up to the dotted line, the tube into the column is also filled. The height of the wine is the same due to the principle of communicating vessels. As long as the level of the liquid doesn't rise beyond the limit, the cup functions as normal. The air pressure at the surface of the wine is equal to the air pressure through the pipe of the base.
But when the wine surpasses the dotted line, then the wine fills the tubes, and there is a leak from the base of the bottle, till the whole cup empties. This phenomenon is called siphonic effect, and this mechanism that the Pythagorean cup is, we call it a drain.
In this case, the atmospheric pressure on the outer surface of the liquid remains constant, and the one from the base is eliminated. Therefore, the pressure at 1 is less powerful than the pressure in 3, which means that the wine will move from higher to lower pressures until it is cooled completely.
So here we can see the Pythagorean cup, and we are going to start our experiment. As we said before, inside the cup we have an inner tube inside, a tube with an inner tube inside, which communicates with a hole in the bottom of the cup. First we put some water inside the cup and see what is going to happen. We don't see something very special, and the cup functions normally. No water is pouring from the base of the cup. But if we put even more enough water in the cup, so as we pass the tube, we will see that the water is pouring through the inner tube and falls from the base of the cup, till the whole cup will empty. And this will continue till all the whole cup empties.
Now let's see how we can build our own Pythagorean cup with a cup of glass and a drinking straw. First, we have opened a hole in this area and we have passed the drinking straw, which we have bent enough so that it looks to the bottom of the cup. Also, we have sealed hermetically the drinking straw and the hole with some silicone. And then we have cut the drinking straw that remains. So let's test it.
We will again put some water in the, but not pass the straw. We don't see if something happens. But if we put enough water, even more water, we will see like before that the water will start dropping from the bottom. And this will continue till the whole cup empties. So we made our own Pythagorean cup.